Hello, networking enthusiasts. Welcome to the channel God of Networking. Today, I will show you how to configure VRRP in SONiC. As we know, in SONiC, by default, all the ports here are in layer 3 and all ports have assigned default IP addresses. So before starting of the video, I have removed all those default IP addresses and assigned new IP addresses that we have to use in our topology. So now I will go into R1. As we can see here, Ethernet 0 and 4 have assigned those IP addresses that we have to use in our topology. Now, the main interesting thing about VRRP in SONiC is that FRR VRRP implementation uses MAC VLAN device. In Linux, a MAC VLAN device is a virtual network interface that has its own virtual IP and MAC address. So before configuring VRRP on R1 and R2, first of all, I will create MAC VLAN device on R1 and R2. So now I will use commands sudo IP link add VRRP instance, which is 5, link Ethernet 0 ADD RGEN MOD resident mode random type MAC VLAN mode bridge. Actually, these are Linux commands. Sudo IP link set dev VRRP5 address 00. This is actually a MAC address of that virtual interface. 5E 00:01, and here we have to assign a VRRP instance, which is a 5. Now sudo IP address add 192.168.10.1. This is actually a virtual IP address. Dev VRRP5 sudo IP link set dev VRRP5 up. Now I will check the status of this VRRP interface. IP address show VRRP5. So actually, what is the function of these commands? Actually, with the help of these commands, first of all, we create or we bind a VRRP interface to that port of the router. Like in this command, we are binding VRRP interface with this port, and then in the next command, in this command, actually we are assigning a virtual MAC address to this VRRP interface, and then in this command we are assigning a virtual IP address to that VRRP interface, and then we are trying to up that VRRP interface. As we can see here in the status of this VRRP5 interface, that virtual IP has been assigned. Now I will save sudo config save. Now I will repeat the same set of commands on R2. Here I will check the status of IP interfaces. Show IP interfaces. Now sudo IP link add VRRP5, which is VRRP interface, link Here which we are using actually Ethernet 4. Ethernet 4 AWGR address gen mode random type MAC VLAN mode bridge. Now sudo IP link set dev VRRP5 address, which is a virtual MAC address 0:0:5E. This is actually a MAC address 5E:00:01:05. Now sudo IP address add 192.168.10.10/24 dev VRRP5. Now sudo IP link set dev VRRP5 up. Now I will check the status of that VRRP interface. IP address show VRRP5. As we can see here on that interface, virtual IP address has been assigned. Now I will go into R1. The architecture of SONiC is designed in such a way that FRR is integrated in SONiC. For all L3 protocols, we have to use FRR commands. First, we have to go into BGP container and then start a daemon process which will run in the background. This is actually a architecture of SONiC. Now I will go into BGP container by using command docker exit it bgp bash cd/users/lib/frr ls vrrp daemon. So now I will go into R2 and repeat same steps. Docker exit it bgp bash cd/user/lib/frr ls vrrp daemon. So now again I will go into R1. As on both routers, VRRP daemon is running in the background. Now I will go into Vitaish configuration mode, VRRP5. Interface 0, interface Ethernet 0, VRRP5 priority 200 because it will act as a master router. VRRP5 priority 200 and then VRRP5 IP, VRRP5. Now we are assigning a virtual IP 192.168 to this VRRP interface .10.10. Now exit. Now I will save configuration using write command. Now I will repeat the same steps on R2. Exit Vitaish configuration mode, interface. In this case the interface is 4, Ethernet 4, VRRP5 priority 100 because it will act as a backup router. Priority 100 VRRP5 IP virtual IP 92.168.10.10. and now exit. Now save the configurations by using write command. Now I will go into R1 and check the status of VRRP. Show VRRP. Oh, now here we can see the virtual router ID This is a VRRP interface, VRRP 5. Here is the primary IP, 192.168.10.4. This is a virtual MAC address. V4 mean IPv4. And here, this is a virtual IP. Here is the actual IP that we have assigned to a port, and this is a virtual IP. Now I will check the status of R2. Show RRP. Now we can see here everything is fine. Virtual MAC, virtual IP. The interesting thing about R1 and R2 for VRRP is that here VRRP, here the primary IP address is not listed, we can see, but in R1 we can see primary IP address is listed. What does it mean? It means R1 is acting as a master router while R2 will act as a backup router. Now I will go to R3. Now as we can see in my topology, first of all I have configured VRRP. Now I will configure OSPF in 3 routers, and then I will generate a ping request from the host. Now I will configure R3. In the meanwhile, I will assign IPs to PC1 and PC2. IP 192.168.10.2/24. Gateway is virtual IP 192.168.10.10. Now I will go into PC2. IP 192.168.10.3, and the gateway is virtual IP 192.168.10.10. Now I will go into R3. R3 is listed here, not, yeah. Admin password is SONiC, which I have set before starting of the video. Now I will check the status of IP interfaces. Show IP interfaces. Yes, you can see here IP addresses have been assigned. Now docker exec it bgp bash cd /user/lib/frr ls OSPF daemon. Now OSPF daemon is running in background. Exit Vitaish configuration mode router OSPF network 192.168.11 and 12. .11.0/24 area 0, 11 and 12. Exit right. Now I will go into R1 and R2 and configure OSPF. R1 exit docker exit it bgp bash cd /user/lib/frr ls OSPF daemon. Now it is running in background. Now I will go into Vitaish configuration mode router OSPF network 192.168 and networks are 11 and 10. .11.0/24 area 0, 11 and 10. Exit right. Now I will go into R2 and repeat the same steps. Exit docker exec it bgp bash cd /user/lib/frr ls OSPF daemon. Now it is running in background. I will go to Vitaish configuration mode, router OSPF, network 192.168. With R2 12 and 10. 12.0 slash 24 area 0 12 and 10. Now I will save configurations using write command. Now I will check the status of OSPF on all the routers one by one. Show IP OSPF neighbor. Okay, neighborship has been established. On R2, show IP OSPF neighbor. Okay, everything is fine. On R3, show IP OSPF neighbor. Yes, neighborship has been established. Now I will generate a ping request from host PC1 to R3. Oops. PC1 to 11.1 ping 192.168.11.1. Yes, host is getting reply or packets from R3. Now I will generate a ping request for 12.1. Yeah, everything is fine. Now, what is the function of VRRP? VRRP means if one router, which is actually a master router, if it goes down, then backup router will handle all the traffic. This is actually a gateway redundancy. Now I am stopping R1. Now I will check by generating a ping request for 12.2. As we can see here, router R1 is switched off, but router R2 is acting as a master router and all the traffic is handled by R2. Now 12.1. Yes, here we can see. Now I will check the status of R2. Show VRRP. As we can see here, as we can see here, now R2 is acting as a master router. When R1 was acting as a master router, it was acting as a backup router and it was not showing any primary IP. Since R1 is now shut down, so R2 is handling the traffic and it is acting as a master router. So primary IP address is shown here. Now I will check the configuration files of R2. Exit docker exec it bgp bash cd /user/lib/frr. Oops. Sorry. cd /etc/frr ls cat vrrp.conf. As we can see here, VRRP configuration file is present and we can see here in the directory /etc/frr. So our main goal to provide gateway redundancy is configured successfully. So as we have seen that when router R1 goes down, which was actually a master router in the beginning, so R2 has taken place of R1 and now it is acting as a master router, and all the traffic is handled by this router. So thank you guys for watching my video. If you want more videos like this, kindly subscribe my channel.